listen back to it if you want. All right. Section by section, numbers 1 through 4. Let's take a look at these first. Estimate each product or quotient. When we see mixed numbers, we need to round them to their nearest what? Whole. And what is the fraction that I'm looking for that's going to determine which whole this mixed number gets rounded to? Josiah. Half. If the fraction that goes with the whole number is half or larger, we round up. If it's less than half, it stays the same. So 9 2/3 times 2 1/5. 9 2/3 is 2/3 greater than half. So the 9 goes to 10. 2 1/5. 1/5 is less than 1/2, so it stays at 2. I believe yesterday we said that it was 20. Now, number 2, with the division, we still round to the nearest whole. However, I've requested, or I've given you the suggestion that when you round using division, do what you're dividing by first, just in case. 1 5/6, if I round it straight up, should be what? 2. Okay? Round the 11 3/4 straight up, and we should get 12. Now, 12 divided by 2 is doable, so that we'll just make that a 6. But in the event that it's not, okay, in the event that it would not be, and this is just kind of a side note to you, because on your real test, when we take that, you may run into this situation. This is why you want to round this first, okay? If you look at this, you say 11 1/4 rounds to what? 11. 11 divisible by 2. Yeah, it can be done. You're just not going to get a whole number. So you may want to use this and say, what number closest to 11 is divisible by 2? It's 10 or 12, right? And then you could say, okay, divisible by 2, and you either get 5 or 6. Okay? Just in case. That's just on a side note. That's not what number 2 says, but just on a side note. Yes? I would accept either 5 or 6. I'd probably accept even 5 1/2 if you did it. Okay? But it just might make it a little easier for you. 3, 29 7/8 divided by 5 1/6. Again, division, so we're going to round this one first. 5 1/6 rounds to 5. 29 7/8, 30. So we're good here again. 30 divided by 5 is 6. Number 4, 4 1/8 times 10 2/3. So 4 1/8 goes to 4, and 10 2/3 equals 44. Okay? This whole rounding, mixed numbers to the nearest whole gave us huge issues last chapter. When we did the same thing using adding or subtracting with mixed numbers after rounding them, it was a huge deal. Are there any questions, any concerns, any confusion as to how you're supposed to do this section? Maybe you had all 4 of them right. Okay. 3 out of 4? Okay. And you see why? Numbers 5 through 12. This is a big section. This is going to make or break your test, most likely, because it's such a big section. Okay? There's certain rules that you need to be aware of when everything has to be, first of all, in fraction form. And are improper fractions okay? We call it A over B form. A can be bigger than B, but we need a numerator and a denominator. Okay? So number 5, with the division, 5/9 divided by 5/6. When I divide, really what we're doing is we're flipping and multiplying by the reciprocal. Very good. As I work, I want to reduce as much as possible so I don't have to simplify when it's all said and done. 5 and 5. And anything with 6 and 9? equals 2/3. Maddie? If I look diagonally here and I say 5 and 5, can I divide them by the same thing and make those numbers a little bit smaller? Yes. 5 divided by 5 is 1. 5 divided by 5, I can divide them both by 5. That's right. Awesome. Yeah, it's the same thing, but I'm not even going to bother confusing everybody. Okay? Let's just do it the way we're supposed to. Okay? Then people will struggle with, well, which one goes on top, which one goes on the bottom, if you know. 2/5 of 35, we said yesterday that of means times. So, how am I going to put this into fraction form? 35 over 1. Anytime I have a whole number, I make it into fraction by putting a 1 underneath it. Am I flipping? No, because I'm not. So Trinity, between 2 and 1, anything? 5 and 35. 5? How many 5s? 2 times 7? That's 14. What was that? Who's just in here? Who was in here? Oh, no thanks. Is that birthday treat?
Yeah.
Happy birthday.
Okay.
Thank you. Good. Number 7. 1 and 8 11th divided by 1/3. Okay. Everything in fraction form? No, not yet. 1 times 11. 11 plus 8 is over 11. I'm dividing, so I need to multiply by the reciprocal, which is going to be what, Maddie? Everyone, you have a question? What? You multiply the whole number times the denominator, 1 times 11. Then you add the numerator, 11 plus 8 is 19. The denominator will stay the way it is. Now, as I look diagonally, there's nothing in common anywhere, so I've got to take this as it is. 57 over 11. How many times can I fit 11 into 57? Brandon? 5 gives me 55, which leaves 2 left over, the 11 on the bottom. Number 8. 1/2 times 3/4. Fraction form, multiplying, I can tackle it right away. 1 and 4, no. 2 and 3, no. 3 over 8. About as basic as it gets. Now, number 9, 2 1/5 times 1 and 1/5. Do we have fraction form? So we need to get to 1/3. Good catch. 2 times 5 is 10, plus 1. 1 and 1/3. 1 times 3 is 3, plus 1. Okay. Anything in common diagonally that I can reduce? Not so much. 11 times 4. 5 times 3. 15. 15 into 44. Trinity? 2 gives me 30. 3 gives me 45. That's too many. So 14 are going to be left. 14, 15. I know. I'm just explaining it for everyone else. I'm not saying you're wrong. Calm down. Okay, are we good? Good? 18 divided by 1/8. These can get tricky if you lose track of what's going on. Everything it has to be fraction form. That 18 over 1 is going to stay 18 over 1. But I'm dividing, so I'm going to multiply by the reciprocal, 8 over 1. Nothing in common diagonally. So 18 times 8, 144 over 1. Okay. 7 4/5 divided by 3. Okay. So fraction form, not yet. 35 plus 4, 39 over 5. What is 3 as a fraction? 3 over 1. So when I flip it, it's going to be 1/3. 39 and 3. 3, right? 1 there and 13 up top. 13 over 5 is equal to? How are we doing so far? $12, 3 times 4 and 5, 7. If we were to just take a second and estimate, we'd estimate and say 3 times what? 5. I should get something in the neighborhood of 15, right? So 3 in fraction form is 3 over 1. 4 times 7, 28 plus 5 over 7. Nothing in common I can do any reducing by. 99 divided by 7. Now, some of you will get to this and you'll just stare at it. Like, don't just stare at it. If you don't know, what should you do? Well, can we just set it up? I mean, essentially, that's what we're finding out, right? How many times does 7 go into 99? So 1 and 7 into 29 is 14. And if that gave us 1, we should have 1, 7. Close enough to 15 where I'm not going to sweat about it too much. Anything else on 5 through 12? You want to get them all right. Missed only 1. Okay. Missed 2? Good. But you know why? Why was it? Okay. Okay, yeah? Okay. All right, well, that's why we do this, so you can make your mistakes now, so you don't make the same mistakes when it counts for real. 13. We said that we were going to do what to solve this problem? We're going to multiply by 2 if we're going to double it. One of those questions, when am I going to need to know this? Well, if you plan on doing any cooking, you will. 8 plus 3 is 11 over 8 times a 2 over 1. Everything in fraction form. 1, 11 over 4. 2 and 3/4. Yes? Oh, here? I had a 2 and an 8. They're both even, so I can divide them both by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. Okay? That's where I get it. 14. Sammy wants to make half. We said that you could either divide by 2 or multiply by half. Same thing. Because if you divide by 2, that becomes 2 over 1. When you flip it, it's half. So it's the same thing. So let's go ahead and just show you that. 1 and 1/3 divided by 2. 4 over 3. Well, if 2 is equal to 2 over 1, when we flip it, it's 1 over 2. 1 equals 2/3. Okay? Yes? That's a 2 times a 1. Okay? And then 15. 10 divided by 2.5. 10 is a fraction. 10 over 1 times means I have to flip. That's 5 over 2, but when I flip it, 2 over 5. 10 and 5, I can divide them both by what? 5. 2, 1. 2 times 2 over 1 is 4. How many cuts will they have to make? There's the board. They want 4 pieces. How many cuts?
4. 3.
How many pieces do you have?
4.
How many cuts do we make?
3.
Yep.
Oh.
1 cut gives you 2. That's where you make up for them. All right, 16 through 21. These are what we call free points. Free points. The only way you're going to botch these if you're really not paying attention. Length of a person's ear, we already said yesterday, was B inches. Weight of an elephant. Okay? A, tons. Amount of shampoo in a bottle. C, fluid ounces. Length of an airport runway, since we already used inches. We've already used inches, I said. Weight of a penny, ounces. The amount of water in a reflecting pool. Don't even ask what a reflecting pool is. You see pool? It's a lot. Okay. Any questions on anything on the front? All right, 22 to 25. Now, we're approaching somewhat of a problem section because in the past, this has given kids a hard time. It's all about if you have your notes that deal with our steps. You can, but I don't know if it's in there. The way we set it up, I don't know if it's actually in your book that way. You have the conversion chart, but 10 gallons is equal to how many quarts? Okay, so I'm going to go from gallons at the top of my capacity down to quarts, which means I'm doing what operation? Multiplication. How many quarts are in a gallon? So I'll multiply the 10 times the 4, and I have 40 quarts. 23. 16 pounds is equal to how many ounces? Now, be careful because ounces are different than fluid ounces, and the relationship between fluid ounces and cups is different than that of ounces and pounds. See, there's 8 fluid ounces in a cup, but how many ounces per pound? 16. So if I'm going from pounds to ounces, again, I'm going down the staircase, which means multiplication. I'm going to have to go 16 times 16. $2.56. Very good.
Yeah, I got that.
48 pints to gallons. Now here, I may have to go 2 steps because on my staircase, I'm skipping quarts. It's going from pints all the way up to gallons instead of pints, gallons. So I'm going to go pints to quarts first. And then I'll convert the quarts to gallons. Because that's where they are in the staircase. How many pints are in a quart? 2. So since we're going up, I'm going to divide by 2. 48 pints becomes 24 quarts. Now, I'm going to convert 24 quarts to gallons. 4 quarts in a gallon, divide by 4, would be 6. 25. 15 feet is equal to how many inches? So feet to inches going down, multiply by what? 12 inches in a foot, 10, and 5, so 180. Okay. Any questions? Another problem area, 26 to 29, the equations. I don't know why you guys are celebrating now. It doesn't matter now. It matters when we take it for real, and you're missing things by puffing out your chest at each other. Equations, we do the opposite. What's happening to x? It's being multiplied by 1/4. It's the opposite of multiplying by 1/4. Divide by 1/4. I'm going to cross that out. I'm going to rewrite it just like that. Now, when you see it, which one flips? Which one always flips? The second one, what we're dividing by. We just said the opposite of multiplying by 1/4 was dividing by 1/4. So, fraction form, let's flip it, equals 24. What is 1/4 of 24? It's 6. $27. Question on 26. Someone say wait. Yes? Always in division, the second fraction always flips. Okay. 27, 4/5 x is equal to 7/10. Okay, so what's happening to x? It's being multiplied by 4/5. The opposite of multiplying by 4/5? Divide by 4/5. Now, everything is in fraction form, and we flip 5/4. 1 there, 2 there, equals 7/8. $28. 3/8 x is equal to 5/7. Okay, what's happening to x? Being multiplied by 3/8. Opposite of multiplying by 3/8. Fraction form times what? Over 3. Nothing I can do with any of this. 40 over 21 equals 1 and wait, you couldn't read your own writing? Wait, so yesterday when you were saying it was a yes. Okay, so if I said that 21 goes into 40 one time, okay? One time. When I take that 21 away from 40, I get 19 left over. See, 19 is still less than the 21, which means I can't fit 19 into, or fit the 21 into 19. Okay? And then finally, there's one that's a little bit different. In order to know what the opposite is, you need to know what's happening first. So when you analyze these problems and try to figure what's actually happening, you need to look and say, well, what's happening to x? Is the way it's written here the same as the way it's been written there? There, x was next to the fraction. Here, x was next to it. Here, x is in the fraction. It's different. So x is actually being what? Divided by 4. So the opposite is to multiply by 4. I don't have to put it in fraction form because that's not a fraction. X now equals 60. How can you always make sure you're going to get the equations right? Take the extra second to plug it back in. Plug it in, 60 over 4. Even if you didn't recognize this as being division, you should recognize it as being what kind of a fraction. Therefore, you would then simplify and ask yourself, how many times does 4 go into 60? And you'd say 15, which is what they told us in the first place. So if you just take, I don't know what you had for this. You didn't have 60. Did you have something else? What did you have? 3.5. So if you were going to, no, it's. I'm not making fun of them. I'm just saying, if you were to put in 3.5 over 4, you don't even have what? 1 whole. So how would it equal 15 wholes? Okay? But you would have seen that, Joe, if you would have plugged it back in and say, wait a second, that doesn't look right. Okay? So take the time when we take the test to plug it back in and just give it the eye test and look at it and see if it makes sense. Chances are you'll catch most of your mistakes then. Yes? Right now? Go down to the office and take care of what you got to take care of. Any other questions on anything that we did? Yes. Well, that's the next order of business that we need to talk about.